Hi, Mr. Wright here, and welcome to this film in which I will run through lots of past IGCSE questions on mean, median, mode, and range. You can download the questions by hitting the link in the description, and then you can work on the questions and then watch me do them, or you can watch the film as you're working through the questions and work alongside me. The questions are in 3 categories for each of the 3 question types, but at the end of the film, I've discovered a 4th question type, and I'll run through a couple of examples of those too. Right, let's get on. Right, question 1. All of these first few questions all involve grouped data. Let's have a look at this first one. The table shows information about the heights in centimetres of 48 sunflowers, right? So we know that the frequencies add up to 48 because this table includes 48 sunflowers. Let's just check we know what this table means. What about these 3 sunflowers here? They're all quite tall because they have heights that lie between 130 and 140 centimetres. So I hope you feel you understand what the table means. And our question here is that we have to work out an estimate for the mean height of the sunflowers. Right, we are going to use mid-mad. We're going to find the midpoints, then we're going to multiply, add, and divide. So let's do that now. Right, the midpoints, 90 to 100, midpoint of 95. Then a midpoint of 105, 115, 125, 135. We found the midpoints, now we're going to multiply. So I'm going to do 95 multiplied by 8 and so on. So 760, 105 multiplied by 12, 115 multiplied by 15, 125 multiplied by 10, and 135 multiplied by 3. Mid-mad, multiply, add. I'm going to add up these numbers here, which will give me the total heights of all of the 48 sunflowers. So if the total heights of all the 48 sunflowers is 5,400 centimetres, each one of them on average will be 112.5 centimetres tall, dividing by the number of sunflowers, 48. And that is question 1 complete. And that would be 4 marks on the June 19 paper 2H. Okay, question 2. The table shows information about the weights in kilograms of 40 parcels. Right, there are 40 parcels here. Write down the modal class, the most popular group. Well, there are 19 parcels that weigh between 0 and 1. There isn't a more popular group than that, is there? So the modal group is between 0 and 1 kilogram. Yes, there are 19 parcels in that group, but we write down which the group is, not how many parcels there are in the group. Work out an estimate for the mean weight of the parcels. Okay, I'm mid-madding again. So first thing to do is to find the midpoints. Now there's a trick. If you're not sure what the midpoint is between 2 numbers, you can simply put them in your calculator. For instance here, 4 plus 5, and then divide by 2. And that will always tell you the midpoint. That's the midpoint. Now I'm multiplying. 1/2 times 19, 1.5 times 12, 2.5 times 5, 3.5 times 2, 4.5 times 2. Multiply, add. The total weight of all the parcels is 56 kilograms. And of course, then I'm going to divide by the number of parcels to work out the mean weight of the parcels, or the average weight of one parcel. There were 40 parcels that weighed a total of 56. So one parcel on average will be 56 divided by 40. That's question 2. Question 3. Oh, question 2, look at that. 5 marks on 1H in June 18. Question 3. 80 students engaged in a dancing competition. 80 students in all. The table gives information about the length of time in minutes for which each student spent dancing. Crikey, look at this. 6 of them danced for almost an hour, didn't they? All right. Work out an estimate for the mean length of time the student spent dancing. Right, mid-mad, halfway between 0 and 12. Halfway between 12 and 24. Again, if you're not sure, you could just do 24 plus 36 and divide by 2. 42, the midpoint between 36 and 48, and 54, the midpoint between 48 and 60. Multiply 6 times 11. 18 times 25. 30 times 23. 42 times 15. You just need to not press the wrong button on your calculator, don't you, while you're doing this? Okay, that's me multiplying. So that's the amount of time that they have spent. And I'm going to add that up to get the total amount of time that these 80 students spent dancing. So what about an estimate for the mean time that the students spent dancing? Well, if 80 students danced for a total of 2,160 minutes, if I divide by 80, I can work out that on average, each student danced for 27 minutes. By the way, why is it asking me to work out an estimate for the mean length of time? Why is what we're doing only working out an estimate of the mean? Let's have a think about that as we carry on, and we can talk about it after question 7. Question 6. The table shows information about the length of time in minutes 120 customers, okay? 120 customers, the frequencies add to 120, spent in a supermarket. Write down the modal class, the most common class here. Well, I see that 31 people spent between 40 and 50 minutes. But look at that, 40 people spent longer than that, didn't they? 40, that's the most popular class, like the one with 40 people in it. So the modal class is the class between 50 and 60. Okay, work out an estimate for the mean length of time spent by the 120 customers. Mid-mad, midpoints, 25, 35, 45, 55, 65. I don't think we need to use our calculator trick to work out those midpoints. Now I'm going to multiply, then add, and then divide. 25 times 6, 35 times 26, 45 times 31, 55 times 40, 65 times 17. Multiply, add. Altogether, these customers spent 5,760 minutes in the supermarket. So what was the mean length of time? How long did each customer spend on average? Well, there are 120 customers, so I'll divide the total by 120. Means that on average, each customer spent 48 minutes in the supermarket. Again, I'm curious to know why that's an estimate for the mean length of time, but that will become clear after question 7. Question 5. The table gives information about the speeds in kilometers per hour of 80 motorbikes. Okay, there are 80 motorbikes represented in this table here. Write down the modal class. What's the most common speed? I'm looking for the class which has the highest frequency, and it is the class where the speeds are between 70 and 80 kilometers an hour. Work out an estimate for the mean speed of the motorbikes as they pass under the bridge. Give your answer correct to 3 significant figures. We don't want to forget that last bit. That would be an unnecessary mark to lose. Right, mid-mad. 40 and 50. 50 and 60. 60 and 70. 70 and 80. 80 and 90. Mid. Multiply, add, divide. Multiply. 45 times 10. 55 times 16. 65 times 19. 75 times 23. And 85 times 12. Multiply, add. 5, 3, 1, 0. And so to find out the mean, I'm going to multiply I'm going to divide the total of all the speeds by the number of motorbikes there were. 5,310 divided by 80 gives me a mean speed of 66.375. But look out, give your answer correct to 3 significant figures. So my answer is going to be 66.4 kilometres per hour. And again, look, that question's 5 marks on January 21's paper. So with any luck, once you practice these, that's a straightforward 5 marks. Question 6, we're almost there. This table gives information about the number of minutes that Abby spent walking each day in September. It doesn't tell me how many days she walked for. It does say each day in September, so perhaps we can assume that she walked every day in September. But to make sure, let's add up the frequencies. 5, 6, 8, 9, and 2. That gives me 30. So she walked for 30 days. Right. Work out an estimate for the total number of minutes that Abby spent walking in September. Look at that. It doesn't ask me for the mean this time. It says work out an estimate for the total number of minutes. So I'm used to going mid-mad. This time I'm going to find the midpoints and multiply and add to get the total. I'm going to divide to get the mean. So the midpoints, first of all, you see these 5 days that she walked between 0 and 30. I'm going to assume that each day she walked for 15 minutes. These 6 days when she walked between 30 and 60, I'm going to assume 45 minutes. 8 days, 60 and 90, 60 plus 90, divide by 2, 75. 90 and 120 gives me a midpoint of 105. And then a final midpoint of 135. Right, so for 5 days, she walked for 15 minutes. 5 15s, that's 75 minutes in total. So I'm multiplying here. 75 times 8, 105 times 9, and 135 times 2. Multiply, so her total number of minutes will be the addition, the total, the sum of all those numbers. And so the total number of minutes that Abby spends walking is 2,160. Okay, that's number 6. Didn't ask me for the mean at all. How many marks was that? 3 marks in June 23. Right. Question 7. The table shows information about the weights in kilograms of 40 babies. Right. Write down the modal class, or the most common class is the class with the highest frequency. So the most common weight for the babies is between 3 and 4 kilograms. Work out an estimate for the mean weight. Perhaps this time we ought to talk about why this is an estimate for the mean weight. Let's first of all do our mid-madding. Midpoints, 2.5, 3.5, 4.5, 5.5, and 6.5. Right, multiply. 2.5 times 12, 12 babies weighing 2.5 each, 30. 16 babies weighing 3.5 each, 56. 9 babies weighing 4.5 each, 40.5. 2 babies weighing 5.5 each, 11. 1 baby weighing 6.5. I've multiplied. Now I'm going to add those together. If I add those together, I get the total weight of all the babies, 144 kilograms in all. So my estimate for the mean weight is 144 divided by 40, since there are 40 babies, gives me 3.6 kilograms. Now, why is that an estimate? The thing is, of course, that if you consider these 12 babies in the top row, I assumed that each of the babies weighed 2.5. We took the midpoint, didn't we, between 2 and 3. Of course, that isn't necessarily the case, that each of the babies weighs 2.5. I know that each of the babies weighs between 2 and 3 kilograms, but I don't know the exact weight of every baby. I'm just assuming that it would be reasonable to take the midpoint for each of them. So that's why this is an estimate of the mean weight. It's because we are approximating the weight of each baby by using the midpoint of each class. Right, part C. Look at this. This finally a question which asks me more than just mid-madding. One of the 40 babies is going to be chosen at random. Find the probability that this baby has a weight of more than 5 kilograms. Let's look at the table. How many babies have a weight of more than 5? These ones. 3 babies have a weight of more than 5. And I'm asked what the probability of choosing a baby would be to have a weight of more than 5. I've lost the question. Here we go. What's the probability of choosing a baby with a weight of more than 5? Well, there are 3 babies with a weight of more than 5 out of the 40 babies. So the probability would be 3/40. Now look at that. That time it's 7 marks. And that is on paper 1H in Jan 2020. So these questions could be worth quite a lot of marks on your paper. And with any luck, you find them quite straightforward now. Right, that's question type 1 finished with. How did you find those questions? Have you got the hang of them now? It would really help me if you told me in the comments whether you have got the hang of those now and whether you found the film useful. In the meantime, let's get on now with question type number 2. Right, question type number 2, finding missing numbers. Let's have a look at question 8 here. Ava writes down 5 whole numbers. Now I'm going to go 1, 2, 3, 4, 5, and these are going to be in size order. Okay. Now for these 5 numbers, I've got this information. Find the possible value for each of the 5 numbers. Find a possible value. Right. Now the median is 7. Now there are 5 numbers, so the middle one is 7, and that's that piece of information used. The mode is 8. Now because these are in numerical order, any 8s need to go to the right hand side of the 7, and the most common number is 8, so these must both be 8s, so there are 2 8s. Mental note, you can't have 2 more of the same number because you want 8s to be the most common. Right, the range is 5, so that means that the difference between the biggest number and the smallest number is 5, so that one is a 3. Okay, find a possible value for each of the 5 numbers that Ava writes down. Well, I found the first number, the third, fourth, and fifth. Now, what about that second number? Could it be a 3? No, because then the mode wouldn't be 8. The mode would be 8 and 3. Could it be 4? Yes. Could it be 5? Yes. Could it be 6? Yes. Could it be 7? No, because then the 8 wouldn't be the only mode. So there are 3 possible answers here. You can have 3, 4, 7, 8, 8. You can have 3, 5, 7, 8, 8. Or you can have 3, 6, 7, 8, 8. And that would have got you 3 marks in paper 2H in January 21. Let's look at the next one. Question 9. Here are 5 cards. Each card has a number written on it. Okay. The mean of the 5 numbers is 12. Wait a minute. If the mean of 5 numbers is 12, then the total is 5 times 12. The total of my 5 numbers is 60. Work out the value of x. Well, I know 4 of my numbers, so I can add those up. These numbers happen to add up to 43, and I can think, okay, what would I need x to be so that the total was 60? 60, take away 43, x would have to be 17. Right. Incidentally, if you're finding this film useful, now would be a good time to hit like. Give me a bit of positive feedback, why don't you? Question 10. Here is a list of 6 numbers written in order of size. Something 5, Y, Z, 10 and 12. 6 numbers written in order of size. The numbers have a range of 9. Aha, they've got a range of 9. Then I know that if 12 is the largest number, then the smallest number must be 3. Okay, I'll write that there. A median of 8. Well, the median can be halfway between these 2 numbers, isn't it? So the median is 8. But because I don't know Y or Z, that doesn't really help me at the minute. The mode is 10. The most common number of these numbers must be 10. Well, there's one 10 already. So if the mode is going to be 10, then Z here, that must be 10 as well, mustn't it? Now there are 2 10s. That's great. So the mode is 10. Now, does that now help me? Because you know how I know that the median is 8. So halfway between Y and Z, halfway between Y and 10, is the number 8. Well, that's a gap of 2, so that would have to be a gap of 2. So y would have to be 6. So I've now got everything, haven't I? I've got x is 3, I've got y is 6, and I've got z is 10. And importantly, I've got 3 marks in January 23's 1HR paper. There you go. Right, question 10 sorted. Incidentally, remember that once I've been through the second and the third question type, this is the second question type, I've got a fourth question type that I have discovered that I'm going to put at the end of the film. Question 11. Right, Alberto, Bill, Candela, and Diana are 4 friends. Notice how they begin with an A, a B, a C, and a D. Here's some information about the height of the friends. Alberto's height is 158. Alberto's height is 158. I'm going to write this here so I never have to read all the words again. Bill's height is 175. C's height is greater than D's. Okay. The median height of the 4 friends is 160. I've got 4 numbers here. 1, 2, 3, 4. The range of the heights of the 4 friends is 21. Right. But I'm going to have to take a gamble here and start and try something, aren't I? I'm going to put Bill's height here, 175. I'm going to assume that Bill is the tallest. All right. Now, the range is 21. So if Bill's the tallest, put a B above Bill, then the shortest person must be 175, take away 21, 154. Okay. Right, now I've got the person beginning with A, Alberto, to fit in here somewhere, haven't I? And I also know that the median is 160. So 160 has to appear here, which means, incidentally, that Alberto, who's 158, he must be here to the left of 160. Now, 160 is in between 158 and something. It's a jump of 2 from 158 to 160, so another jump of 2 gives me 162 here. Well, that might work. Let's have a look. Alberto's height is 58. Good. Bill's height is 175. So wait a minute. Here's Alberto there. Good. C's height is greater than D, so that could be C and that could be D. Work out C's height and D's height. Okay, well, C's height is 162 and D's height is 154. And that's a nice 3 marks there on that paper. Question 12. Here are 6 numbers written in order of size. 4, 7, X, 10, Y and Y. Look out, Y and Y, they're going to be the same number, aren't they? Just repeated. Right, the numbers have a median of 9. Okay. That means that I know that 9 is going to go in here, in between 10 and X. Haha, so I know that X has got to be 8, right? So now I've got 4, 7, 8, 10. The same number repeated twice, Y and Y. The mean is 11. Okay, 6 numbers, and the mean is 11. So the total of the numbers is 66. Right, well, so far, I've got 18, 25, 29 there. And I need the total to be 66. So my 2 y's are going to have to equal 66 minus 29, which is 37. So 2 y's are going to have to add up to 37, aren't they? So each one is going to be half of 37, since I know that they have to be the same as each other. And half of 37 is 18.5. Right, let's have a look. The question asked me for the value of x, which I found was 8, and the value of y, which is 18.5, and that's a nice 4 marks there, which will do very nicely. That's question 12. Okay, hope you're getting the idea of these. If you're finding this film useful, tell me in the comments. If I could be doing something better, tell me in the comments. Right, number 13. Jenny has 6 cards. Each card has a whole number written on it. The smallest number is 5, there it is, on the left, and the largest number is 24, okay? The median of the 6 numbers is 14, right, so in between there is going to be 14. The mode of the 6 numbers is 8. Well, if there are going to be any 8s, they have to be to the left of the 14, don't they? And there has to be more than one of them, because the mode is 8, so that must be 2 8s there. Haha, now just a minute. I've got an 8, and I know that 14 lies in between 8 and this number here. Well, the jump from 8 to 14 is 6, so I have to go another 6, so that must be 20. So the median is 14. All right, now I'm going back to the start now. The smallest number is 5, the largest is 24. The median is 14, and the mode of the 6 numbers is 8. Jenny arranges her cards so the numbers are in order of size. For the remaining 4 cards, write on each dotted line a number that could be on the card. So I've written the 8, and the 8, and the 20. Now, what could be on this last card here? Could it be a 20? It couldn't be a 20, because I know that would fit in the order of them. But if it was 20, then the mode wouldn't be 8, or only 8. There would be 2 modes, 20 and 8. Could be 21, though, couldn't it? Could be 21, could be 22, could be 23, can't be 24 because of that mode. So there are a few possible answers here. You can have 8, 8, 20 and 21, 8, 8, 20 and 22, 8, 8, 20 and 23. Nice 3 marks. Okay. Question 14. I think this is the last in this section. After this section, of course, I will do some IGCSE questions of type 3, and then I'll tell you about the 4th type that I've recently discovered. Right, we've got 8 examinations being sat here by this person. Here are 5 of the marks: 68, 72, 75, 77 and 80. For his 8 examinations, let's put 8. 1, 2, 3, 4, 5, 6, 7, 8. The mode of the marks is 80. Okay, I'll have to come back to that one in a minute. The median is 74, right? So halfway between those two is 74. Okay. The range of the marks is 16. So the difference between the smallest, his lowest score, and his highest score is 16. Find his marks for each of the other 3 exams. Right, okay, well, I have to start somewhere, I suppose. Let's put 80 here. Let's start and hope that 80 is his highest mark. Right, that means his lowest mark is 80, take away 16, 64. Great, okay. Now, what can I work out next? Well, it says here that the mode of his marks is 80. So if 80 is over here on the right, there must be another 80, at least, mustn't there? So that's got to be an 80 there. All right. Now, 74 is the median here. If I look at these numbers, I've got to fit in the 75 and the 77 somewhere to the left there. So it better be 75 and 77. Okay, so I've got the 80 in, the 77 in, and the 75 in. Now, the median's 74, so that means that this number here must be 73, because then 74 is in between 73 and 75. Good. I've got to have a 72, so I'll put that in there. And I've got to have a 68, so I'm going to put that one in there. And I think that finishes off the question. And so the 3 marks which I'm after are the 64, the 73, and an 80. And that concludes those questions of type 2. If you found it useful, tell me so in the comments. If you're enjoying the film, hit like and stay on now for type 3. Okay, well done for staying with it so far. That's the 2nd type of IGCSE question on means, medians, modes and ranges covered. And we're moving on to the 3rd now, which involves combined means of one group, means of another group, and questions around that. They're fine, you'll get your head around them, just stick with the film. After the 3rd type of question, I will show you the sort of question that I've just discovered very recently, which comes up now and again. It's still worth having in your arsenal. Right, let's get on with question type 3. Right, question set number 3, the 3rd type of common IGCSE question on mean, medians, modes and ranges. These involve finding the mean of one group and the mean of another group and combining them, or finding the mean of part of a group. Let's have a look. It's easier than it sounds. Question 15. Ian plays 7 games of cricket, and his mean score for these 7 games is 42 runs. So, games 7, mean 42. Ian is going to play 1 more game of cricket, and he wants his mean score for the 8 games to be exactly 50. 8 games, he wants a mean of 50. How many runs must he score in his 8th game? Well, if we know the number of games that he's played, 7, and we know the mean, then we know in total he has scored 7 times 42, 294 runs. And he wants his mean to be 50 after 8 games. 8 times 50, he'll need to have scored 400 runs in total for the 8 games if he wants his mean to be 50. So this is the total for the 7 games. That's the total after 8 games. So how many runs must he score in the 8th game? Answer, he must score 106 runs. And that is that question done. How many marks was that? 3 marks? Okay. Question 16. 30 students in a class. Students. 30. Sat a maths test. The mean mark for the 30 students was 26.8. Okay. 13 of these students are boys. Let's write the boys here. 13 are boys, and the mean mark for them was 25. Find the mean mark in the test for the girls. Give your answer correct to 3 significant figures. Right, well, what can we work out here? 30 students in the class, and their mean was 26.8. That means I can work out how many marks those 30 students scored in total. They had to score 804 marks in total, 30 times 26.8. Now the boys, how many marks did they score in total? Well, 13 times 25, 325 marks in total. Now, if the whole class scored 804 and the boys scored 325, then the girls must have scored 479, the difference between 804 and 325. I'm asked for the mean mark for the girls. Well, I know their total mark is 474. Aha, wait a minute. There were 13 boys, so there must have been 17 girls. So I can do 479 divided by 17 to get the mean mark for the girls. If I do that on my calculator, I get 28.176 and so on. So to 3 significant figures, the answer is 28.2. And that is question 16 sorted. Let's look at question 17. A scientist is investigating the weight of 50 tigers. Here you are. He's got 22 Siberian and 28 from Bengal, makes 50 in total. Here's some information. The Siberian tigers have a mean weight of 260, and there are 22 of them. Now, the mean weight of all the 50 tigers is 218. Here you are. Here's my mean column, my mean row, 218. Work out the mean weight of the Bengal tigers. Well, I know that there are 50 tigers in all, and the mean weight of the 50 tigers is 218. So 50 times 218 tells me that the total weight of all the 50 tigers must be 10,900. Now look at this. I can work out the total weight of all Siberian tigers, 22 times 260, 5720. So these Bengal tigers, their total weight must be 10,900 minus 5,720. So the total weight of all of those Bengal tigers is 5,180. I'm asked for the mean weight of the Bengal tigers. So the total of their weights divided by how many of those tigers are there? 28. 5180 divided by 28 gives me an answer of 185 for the mean weight of the Bengal tigers and gives me 3 marks. Question 18. 60 students sat a mathematics exam. The mean mark for Class A was 55. Let's write that down. So we've got Class A. There were 32 students, and the mean of those 32 students was 55. Meanwhile, the mean mark for Class B, 28 students in Class B, was 52. Find the mean mark for all the 60 students. Right, well, straight away, of course, I can work out the total of all the marks for the students in Class A. 32 times 55, 1,760. And I can work out the total of all the marks for the students in Class B. 28 times 52, 1,456. So I can work out the total of Class A and Class B. There you go. That's the total of all the marks. So if I want the mean mark, I'm simply going to do the total of all the marks divided by the number of students. 3216 divided by 60 gives me a mean mark of 53.6. Question 19. By the way, I hope you're finding this film useful. If you are, tell me so in the comments. Hit like. If you'd like me to be doing something differently, tell me so in the comments. Come on, it's not unusual for somebody of GCSE age to be critical. So make it a suggestion. How can I improve the film? Or tell me it's going well in the comments. Question 19. Jethro has sat 5 tests. Okay. Jethro's mean mark for the 5 tests is 74. He has to sit one more test, and he wants his mean mark for all 6 tests to be at least 77. Work out the least mark that Jethro needs for his last test. Well, if the mean on his first 5 tests is 74, then his total mark on those 5 tests, all added up, is 370. And if he wants his mean to be 77 on the 6 tests, he's going to need to have a total mark of 462, 6 times 77. So that's his total mark on the first 5 tests, and he needs at least 462 as his total mark on all 6 tests. So how many marks does he need on that 6th test? Well, he needs 462 minus 370. He's going to need 92 marks at the least on that 6th test. Question 19 done. Question 20. Team A and Team B. Okay, here's Team A. Team A, after 11 rounds, has a mean score of 17. Meanwhile, Team B, put them down here, after 9 rounds, has a mean score of 18. Okay. Both teams take part in a further round. After this round, both teams have a mean of 18.5. So let's think about Team A. They've done 11 rounds, so they're going to do the 12th round, aren't they? And after the 12th round, their mean is 18.5. Okay. Meanwhile, Team B, they're going to do another round, so they've done 9, so this is their 10th round. And after their 10th round, their mean is also 18.5. All right. In the further round, Team A scored more points than Team B. Okay. How many more? Right. Well, we've got all the information set out here. Let's think about Team A first of all. In the first 11 rounds, they had an average of 17. So in the first 11 rounds, their total number of marks is 187. And after 12 rounds, they had an average of 18.5. So their total number of marks after 12 rounds is 222, 12 times 18.5. So in that final round, they must have scored 222 minus 187. They must have scored 35 marks in that last round, that 12th round. What about B? Now, after the 9 rounds, they had a mean of 18. So their total after 9 rounds was 162. And after 10 rounds, 10 times 18.5, 185. So Team B, in their 10th round, they scored 23 marks. Now in the question here it says, in the further round, Team A scored more points than Team B. Yes, they did. Look, Team A scored 35, Team B scored 23. How many more? Oh, okay. 35 minus 23. Team A scored 12 more marks. Okay. And that was 4 marks in June 23's paper. Let's look at question 21. We've got a taxi driver. Last week, he recorded the following information. For 5 days, number of days, 5, the mean is 104. That's 5 days from Monday to Friday. 7 days from Monday to Sunday, so including the weekend, mean was 127. Okay. On Saturday, the driver drove 132 kilometres. Work out the number of kilometres he drove on Sunday. Right. Well, from this piece of information here, 5 days, mean of 104, I can work out by doing 5 times 104 that in those 5 days, the driver drove 520 kilometres. Now, in the week, in the 7 days, if I do 7 times 127, I see the driver drove 889 kilometres. So for the weekend then, for the Saturday and the Sunday, must have driven the difference between 889 and 520. Must have driven 369 miles. But of course, we're told that on Saturday, he drove 132. So if I take that away from the 369, I'll be left with how many kilometres he drove on the Sunday. 237. Okay. Question 21 done. Must be almost there. Question 22. I think this is the last one of this section. And remember, after this section, I'll take you through a couple of questions on a 4th question type. Larry is a delivery man. He has 7 parcels to deliver. The mean weight of the 7 parcels is 2.7. Okay, well that means I know the total weight of those parcels, don't I? 7 times 2.7, the total weight is 18.9. Okay. Larry delivers 3 of the parcels. Great. Each of these parcels has a weight of W kilograms. So each of the parcels weighs the same. Okay. All right. The mean weight of the other 4 parcels, the 4 remaining parcels, is 3.3. Well, that means the 4 remaining parcels must have a total of 13.2, 4 times 3.3, which means that the 3 parcels he's already delivered, their weight must be the difference between 18.9 and 3.2. So their weight of those 3 parcels is 5.7. Now the question is, work out the value of W, which is the weight of one of the parcels. And you know that each of those 3 parcels weighed the same. So 5.7 divided by 3, 1.9. So my answer is that W is 1.9. And that is the last question of question type 3. Okay, well done. I hope you're feeling good about this. You've worked your way through those 3 sets of questions now, and you're well equipped for your IGCSE. But I have discovered a 4th sort of question. It's not terribly tricky, but it's worth looking at. And here are a couple of examples. Okay, so here is this question, which is a type of question we haven't covered yet in this film. We've got a frequency table with the information about the number of points scored by a player. I see sometimes they score 0 points, sometimes 1 point, and so on. The mean number of points scored is 2. Now I've got to work out the value of x. Now x is here in the table. X is the number of times that they scored 3 points. Now, I'm going to work out, first of all, how many games the player played in by adding up the frequencies. 13 and 17 is 30, 38. 13, 17, 38 plus 11, 49 plus x. That's how many games the player played in. Now, how many points did they score in total in those games? Well, I'm going to multiply the number of points by the number of times the player scored that number of points. 0. They scored 1 point 17 times. They scored 2 points 8 times, so a total of 16. They scored 3 points x times, a total of 3x. And they scored 4 points 11 times, a total of 44 points. So altogether, the total number of points that they scored is 17 and 16 is 33. 73 is 77 plus 3x. Now I know that the mean number of points scored is 2. So I know that the total number of points that they scored divided by the number of games they played is equal to 2. And that gives me an equation there, which I can solve for x. Let's have a look. I'm going to multiply both sides by 49 plus x. So I've got 77 plus 3x equals 2 times 49 plus x. Multiply out that bracket. 77 plus 3x equals twice 49 plus 2x. Now this is an equation with x's on both sides. I'm going to subtract 2x from both sides. Leaves me with 77 plus x equals 98. Subtract 77 from both sides, and I discover that x is 21. So the player scored 3 points 21 times. Okay, so that's how to solve them. Here's a last example. Question 24. So why not have a look at the question? The frequency table gives information about the numbers of mice in some nests. So some of the nests have quite a lot of mice in them. Look, 6 of the nests have got 9 mice in them. You're told the mean number of mice in a nest is 7, and you're asked to work out the value of x. Pause the film and have a go. Right, I'm going to start by working out how many nests there are in total in this table. So I'm going to add together the frequencies. 4 and 13, and then 16, and then 6, and then x. 17, 33, 39, 39 plus x. That's how many nests there are in total. Now what about the number of mice in these nests? I'm going to multiply. 4 5s are 20 mice there. 6 times 13 is 78. 7 times 16, 112. 8 times x, 8x. 6 9s are 54. So altogether, in the 39 plus x nests, I've got 264 plus 8x mice. And I know that the mean is 7. So I know that the total number of mice divided by the number of nests equals 7. And there's an equation to solve. Multiply both sides by 39 plus x. 264 plus 8x equals 7 times 39 plus x. 264 plus 8x equals 7 times 39, 273 plus 7x. This is an equation with x on both sides, minus 7x from both sides. 264 plus x equals 273, minus 264 from both sides, and x equals 9. And that is the answer to that question. So there you go, a different type of IGCSE question involving means, medians, modes, and range. One that doesn't come up so often, but one which is worth knowing about. Well done, that's it. You've made it through to the end of the 4 types of question that often come up in IGCSE exams on means, medians, modes, and ranges. So I hope you feel good about that. You should be well prepared. If you have found the film useful, leave me a comment and tell me so. If I can improve the film, leave me a comment and tell me so. Any feedback gratefully received. Of course, you can hit like. And of course, if you're preparing for your Edexcel IGCSE Maths exams and you find my content useful, then hit subscribe, and then you will be able to access loads more of my Maths IGCSE content, which I hope you'll find useful. Okay, see you in the next film.